in this video, we're going to do just a couple of extra examples talking about the graph of a function. So let's just go down here. So continuing with this function we talked about previously. So remember, it factors as x plus 2 times x minus 2 over x minus 3 times x plus 1. Okay, that's what we had before. So how do we tell if the point 2, 3 is on the graph of the function? Okay, so what we want to do is we want to check if f of 2, so if I plug in 2 for x, if that equals to 3. Okay, so if yes, then the point is on the graph. Okay, so we can just compute f of 2. So everywhere I see a 2, I'm going to plug, or sorry, see an x, I'm going to plug in 2. I'm going to use the regular form, not the factored form, but you could use either. Okay, so it's going to be 2 squared minus 4 over 2 squared minus 2 times 2 minus 3. So if I compute that, that's 4 minus 4 on the top, and on the bottom I have 4 minus 4 minus 3. So that's 0 over minus 3, which is 0. Okay, so since f of 2 is equal to 0, which is not equal to 3, that means that the point 2, 3 is not on the graph of the function f. In fact, the point 2, 0 is on the graph. Okay, so when x is 2, the y value is actually 0. Okay, so if x is equal to 1, what is f of x? So that means that we want f of 1. Okay, so that's going to be the same as what we did above, but we're going to plug in 1 now. So it's 1 squared minus 4 over 1 squared minus 2 times 1 minus 3. So that's 1 minus 4 over 1 minus 2 minus 3. So that's negative 3 over negative 4, or 3 over 4. Okay, so that means that f of 1 is equal to 3 over 4, or 0.75. Okay, so the point on the graph that represents this is represented by the point 1, 3 over 4 being on the graph. Okay, so that point is on the graph because f of 1 equals 3 over 4. Okay, now similarly, this one asks, if f of x is equal to 1, then what is x? So we want to find x so that f of x is equal to 1. And f of x is like the y value. Okay, so that means we want to solve f of x, so x squared minus 4 over x squared minus 2x minus 3 equals to 1. Okay, so if I multiply both sides by the denominator, x squared minus 2x minus 3, then I'm going to get x squared minus 4 on the left and x squared minus 2x minus 3 on the right. Okay, now I'm going to subtract x squared on both sides, and I'm going to add 4 on both sides, so that I now have 0 on the left. Okay, x squared minus x squared goes away, so then I have minus 2x plus 1. I guess I didn't really want to move the 4 over, but anyway, now I can add 2x to both sides to move the x to by a side by itself. Okay, that's going to give me 2x is equal to 1. And now dividing both sides by 2 gives me that x is equal to 1/2. Okay, so there's only one x value that has y value of 1, and that's x equals 1/2. Okay, so this corresponds to the point 1/2, comma 1 being on the graph. Okay, so you just plug in your f of x value and solve for x. Here we could have got more than one answer, but we didn't. But in the first part above, we could have only got one answer because f is a function. So you can never get two y values out, but if you plug in a y value, it's possible that there's multiple x values that have that. So that's just a few more examples talking about the graph when a point is or is not on the graph of a function.